It is now. So who noticed that A New Hope was the title of the original Star Wars? Raise your hand. Okay, this is going to be awful. There's not that many people. Okay. Well, so first a brief story of EasyBuild at JSC. So it all started in 2013, more or less, here in a supercomputing center far, far away. And it was actually thanks to Alan. There's music, but I thought it's a bit over the top to put the music, so I'll turn it off. But the thing is that it started in around 2013 when Alan was working a project and got in contact with the EasyBuild community, I think through 40s, and he brought it out to JSC in a workshop, and that picked up the interest of some people. I think it was Marcus, Bern were involved on that, then Eric, John later on, and then last year it was me, the one that joined and took over that task. So yeah, now that the thing is over, we can proceed. So before, to understand how we do things or what are our requirements, we have to see what is the characteristics of the system. Well, we deployed EasyBuild on 3 systems. We deployed in Eureka, that's the biggest one. It was the biggest EasyBuild deployment of the world until the guys from CSCS deployed on Pit Lane. So, well, and that's the characteristic of the system. We saw it already on the tour. It's basically a standard Xeon cluster with some nodes with GPUs. The important bit, though, is the user community and the number of projects we have. We have around 1,000 users and around 180 projects. Those were the numbers from last year, but this year will be more or less the same. If they are any different, they are actually going higher. So, with that in mind, what are the requirements? So, there's a thing with queuing in Juelich, I think that's what we call uqueuing, that way. And our users basically, and the people that represents the users in our center, they were basically telling us that they want everything, and they want it quick. So, they wanted Intel compilers, which makes sense. They wanted GNU compilers as well, which might or might not make sense. They wanted also PGI compilers because, well, they want the latest and greatest, and they needed urgently OpenACC support for it. So that's something we had to add. They needed MPI. We have PowerStation MPI in Juelich for a number of reasons. So that had to be deployed. They also needed Intel MPI. They needed CUDA, of course, to use the GPU nodes. And with CUDA, it came CUDAware MPI, which neither of those, so PowerStation MPI or Intel MPI were. And of course, you also needed tons of libraries and compatibility across all this huge mess. So, well, kind of managing that, it gets kind of tricky. And since, well, this is a Star Wars theme presentation, probably this picture makes more sense than the other one of Freddie Mercury winking. So, with all these requirements, all these different compilers, all these different MPIs, all these different libraries and packages that we have to provide, it gets kind of tricky to provide an meaningful user view. Regarding model naming schemes, there's different ways, and EasyBuild supports all of them at this moment. That's the default one, is flat, where you just show everything you have. And that means in our case, on the previous stage, we'll talk about the stage before or later, but what that means that on the previous stage we will have to show 800 packages at once. And on top of that, it's not just that it's completely overwhelming, it's also that, well, this one works with this one, but not with this one, and that gets kind of confusing, especially for people that are not so used to use supercomputers. Then you can have a toolchain-based model naming scheme where you present just the toolchains, and then you load the toolchain, and you show everything that is available to that toolchain. The problem for us with that approach is that we had many different toolchains. So we had combinations of Intel compilers with Intel MPI or with PowerStation MPI or with NVIPH. We have GNU compilers and we have PGI as well. So kind of make a meaningful name for the toolchain, it gets complicated. You can have something short like this thing here. This stands for PGI, MVI pitch, MKL, and CUDA. Easy. Or you can have something long as this, which is also kind of annoying to have. So that's what we had in principle, but we switched to a hierarchical model naming scheme. That's the way we have things currently in Eureka. And the way this works is that you present compilers, you load a compiler, and that extends the model path, and you see the number of MPI runtimes. You load the MPI runtimes, and then you see all the software that is supported on these different levels. Yeah, it's a bit annoying, right? It's moving all the time. Maybe I can use the other one. We'll see if it holds. Let's see if it holds. If not, I'll take the other one. So yeah, and that's more or less intuitive. So when you first log into the system, you don't see much, but the things you see, you know what they are. Just the compilers and a few tools. So that is an advantage. And then to support that, we chose LMOD as a model tool, because if you have things in a hierarchical fashion, then you will need means to find software that is not directly visible, and try to ensure that things are compatible at all times. So that was kind of the main reason. Actually, I'm not sure if no. Okay, yeah, that's fine. Well, it has lots of interesting features besides support for hierarchies. It has good support for hidden models. It has cache to speed things up. You can add properties to models to say, well, this model is compiled with GPU support, for instance, or it's compiled with any other kind of property you can define. It has hooks for different operations and a number of other things that make it way more interesting than using the classical TCL-based models environment. So how things evolved in Eureka? Well, we chose EasyBuild partly because, well, we stumbled upon it with Alan, but it fits perfectly the requirements we had, more or less. It's designed for this use case. It's a package manager for scientific software. It's not for anything else. It's production ready. It has its quirks. It had more in the past than it has now. It still has few things, but it's basically production ready. You can adapt it to your environment easily. It has, well, nice integration with LMOD. It has support for lots of packages. And one thing that I think is very important is that very active, dynamic, and engaging project. We've come into the community, and we can take advantage of. Everyone can take advantage of what we are doing, and vice versa. I think that's something that is very important to take. To don't reinvent the wheel in every single supercomputing center. I think, for me at least, that's one of the key points of EasyBuild, is that it has a very active community around it. The problems we had with EasyBuild at the beginning, which are not now, but they were at the beginning, is that it was based on monolithic tool chains. So that kind of come with a discussion we had in the morning, that, well, you have a tool chain and you have to compile everything for that particular tool chain. And then if that tool chain includes MPI and you are just compiling CMake, well, you are compiling CMake on a tool chain with MPI, which was kind of awkward for us. It pulls in lots of auxiliary libraries. That was especially true for the X environment, where in many cases you don't necessarily want to present that to the users. You don't want to have, I mean, as a user, you don't care if you have libx, whatever, or any other kind of helping library. That kind of, well, sum the model view. And if you had software that just compiled with GCC, but you had an Intel-based toolchain or any other toolchain based on a compiler different than GCC, you couldn't present that particular piece of software in a toolchain based on Intel. And, well, there were cryptic toolchain names, but that I already mentioned that. So we implemented a few enhancements. we enhance the dependency resolution. That's basically through using minimal tool chains. So now the tool chains, they sit on different levels of the hierarchy. So you have dummy, then you will have the compiler, then you have the MPI, and on top of the MPI you have the mathematical libraries. And you can have each piece of software, you can have it installed on the proper level of the hierarchy. You don't have to make it on top or anywhere in the middle. If you want to present that software on that level, you can install it on any level of the hierarchy, and if that's a common branch of the tree, that would be available for both the users and for any other piece of software that you want to build on top. Then there was we implemented a common layer for compilers, and that's partly because most compilers rely on GCC one way or another. Intel relies on GCC, PGI relies on GCC. Those are the ones that we care most about. I think IBM Excel also does to some degree. So it makes sense to have a layer below the compiler. That's what we call GCC core. And that's where we can put all this stuff that don't really belong to you don't really need to compile the X libraries with the Intel compiler. And sometimes it breaks. So keeping it on something that is common, like GCC, which is what most people are using for these kind of libraries, kind of makes sense. Support for hidden modules to eliminate all the clutter from all these auxiliary libraries. We don't really need it. It is supported in various ways. And recently that was extended also to support hiding tool chains. We are hiding GCC core, so because that would be confusing for a user to just log in the system and see module GCC core. What's that? I don't know what is that. But if you load the compiler will automatically load the GCC core that it needs underneath. Well, there's other minor changes. There were custom model naming schemes. We also implemented naming scheme independent software installation. So the software now is installed in a way that it has nothing to do with the model naming scheme you're using. That means also you can change model naming schemes kind of on the fly, or regenerate your model structure. There were performance improvements, refactoring of MPICH EasyBuild. That was important for us because we have MPIs that depend on MPICH but are not MPICH. So have refactoring that family of EasyBuilds was interesting. And this one was, well, Kenneth mentioned it in the morning, and that's important for something that I will let you know a bit later. So what is the current state in Eureka? This is the toolchain we have currently, the tree that we have. We have dummy, we have CUDA sitting in dummy, so everyone can use dummy or CUDA at any point. And we have GCC core based on GCC 540, and all these compilers sit on top of GCC core. Now this was different, slightly different before, basically because of CUDA. CUDA needed GCC 4.x, 5 was not supported, and also it was not very clear if the Intel compilers were really compatible with GCC 5. So we had, on the previous stage, we had to have the GCC core level completely duplicated. We have 5.3 at that time and 4.9.3. And for all these packages, that means that we had now around 130 packages, so we had twice as much for that issue. And well, yeah, and then we have all these different compilers. The reason why we have Intel 2017 and 2016 .4 is because of CUDA, and these tool chains here are supposed to be focused on GPUs, and that's the reason for it, because CUDA, even the latest version, doesn't support the latest Intel compiler, which is kind of an annoyance because you have to duplicate things again, but there's no way around it. And then at the MPI level we have CUDAware and VIPitch. There was a question, I think. Yeah, okay. We have Intel, we have PyStation and VIPitch for the CUDA tool chains. And on top of these MPI libraries we have a single set of mathematical libraries. For the Intel toolchains, that's NKL, and for the others is based on OpenBlast, LabBag, and ScalaBag, and FFTW. And I think now for this as a question.
Right. And the question is, I see the CUDA being very much on the lower layer, but CUDA is known to interact with the compilers in particular ways. Do you have a comment on that? Why it is even below GCC core instead of being 1 or 2 layers even higher?
I'm not sure I get your question. You mean with CUDA, regarding CUDA?
Yeah.
Why we don't put it on GCC core?
Yeah, it looks like it's something that it can depend on the compiler, right?
There's what we had before CUDA. We had it on the compiler level, and we actually had a wrapper that wrapped around a particular compiler for each one of these tool chains. But that had some limitations. The problem, well, there were different problems, but one of them was that there were people that wanted to have, they wanted to use CUDA with a non-CUDA-aware MPI. So if we have CUDA here at this level, that means that if anybody that wants to use it on this tool chain, they can't. So that's the reason why it is lower than the compiler level. Then the question is if we put it on the dummy or on GCC core. I went for dummy basically because dummy is where we have all the binary packages. CUDA is basically a binary package. So we put it there. We don't impose constraints. And then if somebody needs to use CUDA and it doesn't need to have any particular compiler for it, they have it visible. Well, otherwise you will have to load the compiler, and you wouldn't see the CUDA module if you don't load the compiler. So that was the reason, just to try to simplify things and make things a bit more similar to how people will have it on their cluster, on the department, or even on their laptop. If you have Linux on your laptop and you just install CUDA, you just have CUDA there. You don't need to load a compiler and then have to load the compiler. So that was to make that kind of stuff easier, and to allow to use CUDA on non-CUDA-aware MPI toolchains. So far we haven't got any complaint about it. Well, we had a few complaints when we had it on the compiler level. So that was the reason people were like, well, you're forcing me to do that, I don't like it. But okay, we can make it better. So we put it at that level. We also provide wrappers for each one of the compilers, but of course you have to load the compiler first. So if you use the wrapper and you didn't load the compiler, it won't work. But the wrapper is something that has been kind of developed in here. Nobody else uses it. I'm not even sure if people uses it here, so it's kind of a minor thing. Rob has a question. Wait for the mic. Explain the wrapper. No, the wrapper is extremely simple. It's MVCC underscore and the name of the compiler, and then inside it uses the -cc bin switch, and it passes the proper compiler. It's extremely simple.
It's to make sure that the CUDA compiler uses the right C or C++ compiler. You have to tell it.
Yeah. If you don't tell MVCC that you want to use any other compiler, it will use GCC by default. And then if you want to use any other, you have to do it with -cc bin, and actually that's the only way of doing it. It doesn't accept any environment variable or anything.
You haven't found any use cases beyond. Well, I'm just thinking, like, is it a generic? Is it wise to have a generic hook there that you might insert other things into in other cases? Like, this is one exception, but are there other generic exceptions like this that might always make sense to have a wrapper there? You haven't found other use cases. You don't have anything else other than this CUDA narrow.
No. We just have it on this particular case to kind of help people to notice that if they don't do anything, MVCC will use GCC even if they have the Intel toolchain loaded or PGI or anything. It's something very extremely simple.
Actually, I think that you do have a different use case. Don't you have MPI wrappers as well? Somewhere, like you install additional wrappers with the.
We don't do anything.
Some, maybe Marcus, is that yours? No. I think some of the MPI installations install additional wrappers.
Well, the MPI compilers, they are
they
wrappers
have
themselves.
wrappers already.
They are wrappers. It's not that they have, it's that they are wrappers. But
So when someone compiles using that calls your wrapper, and then your what's the order of the?
the order is if you want to compile CUDA code,
Is it MPI CUDA? Is there MPI CUDA code?
yeah, and then normally for that thing you will have to set the backend MPI compiler. You will have to set it to MVCC, I think, but I'm not an expert in CUDA.
Yeah, it's
so
interesting.
and then you can, on that case, you can simply set to MVCC underscore ICPC.
It's neat.
But I'm not a CUDA expert, so I can't really tell you what is the usual workflow for that kind of stuff. I don't do CUDA coding myself. So, any other question?
Okay.
The thing I was referring to, there are, for Intel MPI, there's a set MPI wrappers thing that makes sure there are aliases or wrappers defined, and I think it was one of you that added it. But so that's another use case of compiler wrappers. Yeah. So maybe it may be interesting to look into these use cases altogether and have some generic way of creating compiler wrappers in EasyBuild, because the RPod has the same thing.
Mm-hmm.
So we now have 3 or
So
4 use cases.
kind of add another class that has methods to generate wrappers.
Something like that, yeah. An easy
That-
way to...
Yeah, that might make sense to have something more standardized instead of
yeah,
having
it
different
works
pieces
all
of
now,
code.
but now it's a little bit different, and if we keep doing stuff like this...
Especially I'm not aware when the wrappers aren't aware of it, or at least the when you're building it, you know the wrappers that are likely to be called. But sometimes, like with EasyBuild with our path, we're adding another wrapper in there, and we need to make sure that we get out back to the actual LD or whatever eventually. Like otherwise you end up with like compiler loops, right, or wrapper loops.
Now, on that case, in this case, this particular case, the wrapper is not called as the original compiler, so there's no way you can keep in a loop. So yeah, well, progressing with user view and hidden modules. Well, that's for our model naming scheme. That's the initial user view. You log in the system, you see the compilers on this. Right now, you see these 4 compilers. And then you have a set of binary tools, mostly VTune, Advisor, Total View. There's also CMake, because somebody asked for CMake in dummy. They wanted to have CMake without loading any module, so that was made available as well, and a couple of other things. Then after loading the compiler, it shows on the branch that you chose, shows the MPI runtimes that are available. It shows the packages that have been built with GCC core, and it shows the packages that have been built with that particular compiler. Now, somebody might wonder why don't we kind of preload GCC core to just show all these packages already, instead of waiting to choose a compiler. If these packages are something that are sitting underneath the compiler, maybe you shouldn't load the compiler to show them. The reason is that in some stages, depending on what are the particular dependencies and interactions between compilers, CUDAs, MPI, and all that stuff, you might need to have 2 separate GCC cores. And then is the question, which one do you show? If you show one that is not compatible with the other branches, then the users won't see them. So that's the reason for it. So then user chooses a compiler, it loads an MPI runtime, and then he will see the number of packages, the packages built with that particular combination, and also all the packages built with mathematical libraries on top. So the hierarchy on this case, even though the toolchain has different levels on the hierarchy, we expose on the modules level, we expose it just at the level of compiler and MPI runtime. And then if a user loads another compiler, which wasn't the one originally loaded, then Elmod will take care of swapping all the models that from one branch to the other, all the models that are loaded. And if one of the models is not available on the new branch, that model will become inactive. That's done using families, and that's, as I said before, that's one of the reasons to go for LMOD, because otherwise there's no way to do this. Important is that not all packages are visible at once, and even for the particular combination you have chosen, there's a lot of packages that are hidden. Currently, there's roughly 200 hidden packages in stages that require 2 GCC cores. That's roughly 400 packages that are hidden, and that's a common complaint, like this software is not available. How is that possible? And then, well, it is available, but that comes later. There's a section with common problems we've seen with our way of managing software, and that's one of the common things, so I'll cover that later. Then regarding bundling extensions, we use bundles extensively. There's packages like R, Python, Perl. All of those have a lot of different small modules, and you really don't want to have those as separate modules on the environment. So, a loud sound? Okay. Oh, well, I'll prefer that one. This is kind of annoying. Okay, is it better now for the people of internet? Give some feedback on IRC. Okay. So we use extensions, bundles extensively. For Python, we have Python packages that include roughly 30 extensions. We have a SciPy stack that has 22 extensions, PyQ with 6 and NumPy with 2. The one for SciPy stack is kind of interesting because there's a lot of people that needs NumPy, and there's no module called NumPy, and they go like, how don't you have NumPy? Well, we have it, but it's on the bundle. For R, we have a single R module that includes 365 extensions. That's something that you really don't want to expose as separate modules. Perl, and kind of new is X over G that has 230 different libraries. That's something that has been added on the latest stage, and that kind of it's a complementary approach to the one that Kenneth has integrated already on EasyBuild with his how do you call it, X11. That's an easy blog, and has their own set of easy configs. So the difference is that Kenneth follow the more EasyBuild approach of having an easy config with extensions where you detail library and version. And we rely on JHBuild, and JHBuild is more brute force. You pass it on, I think it's an XML file, and it builds everything that is for that particular software. So it goes on the Git repos of X over G, downloads everything, and installs everything. Difference for us is that this comes with Mesa, while the one from Kenneth doesn't come with Mesa. That's probably the biggest for users, probably that's the biggest difference. Then for finding software, so we've seen that's we have more or less complex hierarchy, and finding software becomes tricky, especially if you come from a system where you have a modules environment based on Tcl and everything is flat, and there's just a handful of modules.
So it's just a question on the RC, and it's probably a good one, is there an easy way to query what bundles are installed? So if I want a particular, like NumPy, right?
Yes.
How can I find where, if it is installed or
the
not?
people on IRC are jumping ahead of themselves. So that is coming. That is coming. That's probably the next bullet point, I think, or the next two. Do I have to repeat the question? No. Okay, Alan had the mic. Okay. Well, so the way we we encourage users to navigate software is using 3 commands and 1 option. So there's module avail, or available if you want to fully spell it out. And that's the one that everyone knows. And you might want to use that option if you're looking into kind of software that is not that common, or the auxiliary libraries and stuff like that. So if you show hidden, it will show you which models are available but are hidden. And lots of people forget about that one and think that something is not installed when it really is. Then there's a spider, and a spider, what it's going to do is crawl all across all the module tree, and it will tell you how to, if it finds the piece of software you're looking for, it will tell you the different modules that have that name with different versions, and then if you tell the particular version, it's going to tell you how to get to that. You have to load this compiler and this MPI runtime, and then you will have it. Or you will have to load this stage because that's available on one stage and but not on the other. So it will tell you how to navigate the module hierarchy. Important is that the spider goes looking for a name, a module name. And that comes, this is the question that somebody in IRC had. On the bundles, for looking what is on the bundle, you need to use module key. Module key is similar to module spider, but it's going to look into the description of the module, not on the name, but on the description. And we have in the description the list of all the different extensions that have been installed on that particular bundle. So for looking for NumPy, you will type module key NumPy, and it will show you, well, this is what I found. It seems like it's in SciPy stack, and then you can use Spider to know how to get to SciPy stack. Yeah, I think that's all I wanted to say about that. Yeah. Then for upgrading and retiring software, our strategy is based on what we call stages. Stages are simply directories where we deploy a new set of software every 6 months. That's the main upgrade we do. That comes together with a new set of projects, and that's in May and in November, every 6 months. And that's to encourage new users to use the new compilers, the new MPIs, the latest software that is available at that point of time. Now, some people doesn't like it because they are like, well, if you're changing the software every 6 months, that's not a production machine because we have to recompile again, and that's actually not true because they can load the old stage and keep using the software as it was until now. This is a small change on their workflow that they just have to load the old stage before they keep working. But that's something that can be done extremely easy. So that's a bit of balance between either you keep everything forever, and at the end of the life of the machine, you have thousands of packages visible at once, and it's a mess, and everyone complains because it's just a mess. There's too many packages. I can't find what I'm looking for because I'm looking on the screen, and there's just too much. Or having something that is completely static, and then people will complain because, well, this has a bug, and the new version doesn't have it, or this has a new feature, and I want it, I really need it, and the old version doesn't have it. So there's a bit of balance between these two things, and yeah, that's our way to approach this issue. We have also a development stage where new software that is intended to be deployed in production, but it's not there yet. There might be some quirks with the way we are building it. We might not have found yet the proper dependencies, or maybe people are testing out a new stage that is not yet complete and they want to add something on top, but it has the dependencies from the old one. So there's this development stage where people can test their buildings and their deployments, and once that gets done, they contact the software manager, we review it, and that gets added to our golden repo that contains all the easy configs that we deploy in production. It's close to seamless transition between stages and maintenance time. So there's maintenance, nobody can log in. We switch the default stage, and when they log in again is the new software stack. It's close to seamless for some people. For others, they might find small issues, which I'll go over them on a couple of sections after this. The stage. I'm not. Yeah. Well, the question. There's a question on IRC, I guess, that Kenneth is forwarding me. Is how we implement the stage. Is it symlinks? Is it directories? How's that? So we have a directory somewhere on the path. It's called stages, and we have all the stages. We have them there. 2016A, 2016B, soon 2017A, and those are directories. And that contains the software and the modules. And then we have, for the default, we have a set of default, a directory where the default set of modules live, and those are symlinks to the current, to the stage that we want to make the default one at that point. That's more or less how it's managed. It's something simple. It's nothing really fancy. And then we have this something that I think I'm not covering on the talk for deploying on one stage or the other. We have stage models. Those models set a particular environment variable, and that environment variable is consumed by another model. We call it developers install software. And that one sets all the environment for EasyBuild and sets on which particular paths the software is supposed to be installed for the stage that you have loaded at the time. If you don't have any stage loaded, then it refuses to load.
There's another question on IRC.
Another question.
I can answer it too as well. So he asked, like, how does these stages interact with the spider cache? And so the way we set up the spider cache is that the spider cache can see all the different stages, but the user path only sees a particular subset. And if you don't use the DBT databases in LMOD, that works fine. So they don't see certain things. So they only see what's visible in their current module path. But everything is actually in the cache already. So once they use a certain path, all of a sudden they access the other software as well.
Yeah. So basically, LMOD does what it's supposed to do. If it's something that is reachable, it shows you. But in the case there might be things that are not reachable, you just have to manually type module use whatever to extend the module path, and then LMOD goes like, oh, all this software that is on the cache, now I can actually get to it. So yeah. And yeah, I think that's everything I wanted to mention about that. One thing is that by default the stages are not visible to users, so they always see the default stage but nothing else. But there's a way to get to it. It's actually documented on the website. It's simply module use the local software Eureka, other stages, and then you'll see the stages models. Now, to try to ensure consistency and decent quality, well, we divide the people installing software. We divide it in two parts. There's the software team and a software manager. The software team is anybody on this particular team, and they can install software just on the development stage. Then when their solution has converged to what they want, where they have that particular piece of software with all the options they want, they tested them ideally, it's working as it's supposed to, it has the dependencies correctly set, then send me an email. It's like, well, that's done, can you move it to production? And we take a look at it. We see if the EasyConfig itself is it doesn't have any hard-coded path or anything that really makes maintenance more difficult. And if it does, we change it to make it more more maintainable and dynamic. And then we move it to production. And we put it on what we call the golden repo. Those are the EasyConfigs that have been moved into production. Yeah, and then the software manager is the only one that is allowed to install things on production. That's basically the main difference, and that's the one managing the whole infrastructure. Before it was Alan, now it's me. So yeah, How we what is the difference between upstream, EasyBuild, and us? Well, we diverge, and the reason for that is mainly that we want to deploy a new stage every 6 months, and that the latest software at that moment might not necessarily be on EasyBuild. That's one thing, and the other thing is that we wanted to reposition packages on the hierarchy at the proper level. Really, a clear case is having CMake on a tool chain with Intel compilers, MPI, and NKL. Really, there's no need for that. So we put a lot of effort on moving packages around and putting on the proper level on the hierarchy. But most differences are small. Maybe just different versions of software. We have version 3.4 and the one upstream is 3.3. Different version of dependencies, obviously, different tool chains, and that's important. We don't use OpenMPI, for instance, so we don't have FOSS. Our main tool chain is Intel and Parastation MPI, which are not upstream. So those are the differences. But in most cases, they are small. So DC configs themselves or DC blocks themselves also, most of them are the same or just small tweaks. Just to give some numbers, in the 2016 A stage, that we have now 2016 B, but the numbers I calculated for a paper, so I'll just reuse it now. We use 47 EC configs that are available as is on the upstream, and we tweak it 777. That's a very particular number. But those are just, in most cases, not always, but in most cases, as I said, they are small tweaks. It doesn't mean that we have rebuilt or redone absolutely everything. Tool chains, we use, at the compiler level, we use 3 tool chains that are available upstream, and we don't have anything in particular at that level. And then for MPI, we use 3 that are available, 3 that are ours, and full tool chains is the same, 3 that are available upstream and 3 that are just ours. AC blocks, we used roughly 65 of them that come from upstream. We took it for the 2016 A stage 5. We tweaked and merged another 5, and we had 4 that were private. I think probably at this point, these 5 that have been tweaked but not merged, probably they are merged at this point. I can't remember all of them, but I don't think any of them stayed exclusively with us. Well, now I have a short demo regarding how we present models to the users. I'm not sure. How are we doing on time? It's kind of late. Yeah. Well, maybe I'll skip the demo. The demo is simply showing what is the amount of packages. If with our scheme, if we present all the packages in a flat view, that would be a total mess. If we do it on as a tool chain like we had before, it's okay. It's getting better, and that will show how things look like when you load the compiler and you load the MPI. But that's nothing groundbreaking, so I think I'm going to skip it to try to keep on schedule. Porting to other clusters, we use that setup and we deploy it on Europa 3 and on UAMs. Those are very similar. You saw them on the old compute room. They are similar to Eureka, but there's small differences on microarchitecture. And on the OS, all of them are based on Red Hat, but all of them have different versions of Red Hat, or Scientific Linux, or CentOS. And one has Xeon Phi and GPU, so there's small differences. But we could reuse most of it with minimal changes. Yeah, so that's more or less to summarize. We deployed close to 700 packages in both of them, and out of these close to 700 packages, just 15 were needed for Europa 3 and UAMs. All the others came directly from Eureka. Common problems with our way of doing things. Well, there's one I mentioned before. User complains about whatever software not being available. My answer normally is like, don't trust your eyes. They can deceive you. If I'm in a bad mood, I will be more like, I find your lack of faith disturbing. Sometimes comes with a forced choke, especially if the user is like the third time asks the same thing. So that kind of get on my nerves. Our LMOD answer is you underestimate my power. And really, if you take a look at what LMOD does, and you just have to use these three commands: avail, spider, and key. There's nothing else. It's not really super complicated. That will show you absolutely everything that is installed. So yeah, most of the time it is there, but it's either hidden, bundle, or in a different toolchain. Another user might complain about nearly missing modules. So there was a module that they had before, and they can't find it now. That not typically happens after a stage update, and that comes when the user specifies a particular version. And in 99% of the cases, it's simply that, well, we have the same software, but a different version. So just load the new version, or use the old stage if you really need to stick to that old version. Yeah, missing libraries also after a stage update. Sometimes they link against a particular version of the library, not libgsl.so, but libgsl.so.19, and the new one or the old one was different, so that is not found anymore. So there's a small quirks, but nothing really complicated to solve. Similarly, the user loads some modules, tries to run their code, and it complains with something like this. So there's a version, whatever, not found. So that's required and might not working. And that comes sometimes when you load certain binary tools that pack together system libraries. That's common with VTune or Advisor. They have their own glibcxx, and normally those are older than the ones that we have. So if you compile your software with our stack and you load VTune at the end, then that library is going to be v4 on the LD library path than ours, and that's not going to work. The solution is simply, well, load VTune first and then everything else, but that's kind of hacky. It's really something that shouldn't happen. Or maybe for this kind of thing, we should look into appending things to LD library path instead of prepending. But that's also, yeah, it's maybe it's not the best solution either. So that's something we'll have to see. Or RPath. Or RPath. No, but the code of the question. There was the comment from Kenneth for the people on the internet that that you can use RPath, and yeah, that's true. If you use RPath on your code, then your code is going to find the proper library. And then if the library of VTune is before on the LD library path, it doesn't matter. It shouldn't matter. Now the problem is that if you, instead of using RPath, if you use runpath, then you will have the same problem again. So so that's something to consider. More problems, and these are not problems for the users, but are problems for us. There's a lot of interactions between different components that forces us to do a lot of duplicated installations. Intel and PGI are examples. They need particular range of underlying GCC versions. They, I think, Intel now supports GCC 6. PGI, I think it doesn't. And then CUDA is particularly picky. It doesn't like any of the latest. So if there's any version of the compiler that comes after the latest release of CUDA, that's not going to work with it. And sometimes even worse than that. For instance, on the latest CUDA 8044, that came after the Intel 2017 compilers, but it's not compatible with them, because I guess their internal testing started before Intel released that version of the compilers, so they didn't approve the use for it, even though probably it will work, but it's just not supported by CUDA. So that forces us to duplicate a lot of things that are really not ideal. Stage updates. That's also a lot of hassle to find new software versions. For every stage update, you have to go software by software looking on internet. Is there a new version of it? Sometimes it's really easy, sometimes it's not, because some packages have this kind of obscure way of releasing things. And then you have to update the dependencies for all the packages, and that's very tedious. And also, well, kind of unavoidable, new software, new bugs. So sometimes there's a new stage, and a particular software is not working with the new stage. Well, I can't fix the Intel compiler, sorry. So the solution is simply switch to the old stage and keep working with it. And that's a fine solution, I think. Then another set of problems for us as well is a side effect of having a centralized software manager, that everything goes through one or two persons, is that every problem becomes an EasyBuild problem. Like an issuer doesn't find a library, that's an EasyBuild problem, obviously. Or doesn't find a module, that's an EasyBuild problem. It happens that the one that installs it knows the solution to it. It doesn't mean that it's an EasyBuild problem, even though for some people it might look like that. The answer to that is normally these are not the experts you're looking for. You should look for somebody else. But yeah, that's not a problem, not so frequent anymore. That within some discussions on the team, that was more clear what is the role of everyone. So that is not so much of an issue anymore. And the reason why I'm putting this kind of issues here is because it's my understanding there are some people that are looking into deploying similar solutions to us. So I would like to make everyone aware of what are the kind of small things we see with our setup. All in all, I think it's been working great, and it enabled us to deploy a really large amount of software that wasn't possible before. And the last problem is that user complaints about not being able to unload a sticky module, and of course you have to use the force. Minus force. That has never been an issue. I think it's here. That has never been an issue, but you know, Star Wars team, I had to make that plan. So future work or what to change. Things that I would like to work on are automatic upgrades of dependency versions. Look into what is installed, and if that EasyConfig tells I need this software with version 3.3 and we have 3.4, well, just don't tell me it's not available. Just update it to 3.4 automatically. That's something I would like to work during the hackathon. We would like to look into RPath. We would like to look into Octave extensions. There's people that has been asking us for Octave and a set of toolboxes for it. There's no support for it at the moment. We would like to implement that to cover those use cases. And we are also interested on fat EasyConfigs with YAML format, because having all these different EasyConfigs that essentially say the same is it's simply annoying. It's nothing else. It's not a big issue, but it's just a bit annoying. We will reshuffle packages, particularly Python. We have it now at the compiler level, but some tools on GCC core needs Python as well. And we've been testing if the performance of Python compiled with Intel or GCC really makes a big difference. And really it doesn't. So probably we will move it to GCC core. Important though is NumPy to have it linked with a proper BLAS library. It's Python with some of the packages, not all of the packages. SciPy stack will stay at the top level of the toolchain, among other things because it needs BLAS libraries, and BLAS sit on top, so those will be there. But the core Python that has these few extensions, that one probably will move it to GCC core to avoid this hassle. What we're doing currently is we have a Python version and another one that we call Python Bear at the GCC core level, but it's kind of cumbersome, and having Python at the compiler level doesn't really bring you much. So most probably we'll move it on the next stage to GCC core. We would like very much to start tracking models, but I think there's another question from Alan.
Have you tried this benchmark?
Alan asks if we tried the Intel benchmarks that ships with the Intel Python distribution. I haven't myself. I've tried. I've been benchmarked. There's another set of benchmarks for Python, more generic ones, and I have some plots for it with different Python versions and different compilers and different compiler versions. And actually, the one that performs better most of the time is GCC. For the ones for Intel, that's something that I would like to look into before actually making this change. But my expectation is that that's going to be a big difference for the numerical related packages. But for everything else, I don't think it's going to make any difference. But I would like to verify it. Kenneth basically agrees with me. So, for the people of the internet. What else? We would like very much to start tracking model usage. Not necessarily maybe with Xalt, but knowing which models are used. At least have a rough idea. Because at the moment, we are just brute forcing everything from one stage to the other. We just move everything. And that takes a lot of time. It's a big hassle. And it might not be necessary at all. But at this moment, we just don't know. So we take the safe approach of just doing it. But I would like to look into tracking model usage. It's just a matter of finding the time to implement it. Kenneth has it, so huh? Yeah, but the question is not really the version of Helmut, is the time to implement that. Because you have to look into the hook, what you want to plug in there exactly, and that's I just didn't have the time to look into it. No, for sure, probably it's not complicated. Fotis, for the people on the internet, Fotis said that it's very easy. It's not complicated at all, and he's probably right. But as I said, it's just I didn't even look into it. It's something that I want to look into it. I didn't even look into it. So that's the reason of why that hasn't been implemented yet. Something that I would like to discuss maybe internally is if we want to preload the stages by default or not, to avoid these people that are complaining that, well, you are forcing me to recompile every 6 months. That is in part intentional, because new compilers might have new features that you might benefit even if you don't do anything. That's true for vectorization mostly, but I doubt that at least for Haswell really that would make a big difference at the moment. But that has some hassle for users. So I wonder if it makes sense to don't preload the stages by default. And when the user logs into the system, just see stage wherever, 2015B, 2016A, 2016B, 2017A, and just pick one, and that is already on their workflow. So we don't disrupt their workflow when we change stages.
There's one clear downside to that. Module spider will see everything. And that's the downside, right? So if you module spider, they see whatever package in all different places. So the spider out is like pretty
There's a comment from Alan saying that the downside of that is that the modular spider will show absolutely everything, so that might be a bit overwhelming. There's another comment from Rob. I can just.
When you're setting up your stages, the paths that you're setting, do the users get the staged path, or do they get the or do you set a default path as well? Like, do you have some global default path?
global default,
Yeah.
But then,
Yeah.
but when they're loading, they're always compiling against the actual stage, so their links don't change. Like if they did our path, it wouldn't change, or if Yeah, and like LD library path would work even easier.
Yeah, the software is always on the same place. It's not moved. It's
And
not.
how often do your stages have
We
code?
change stages every 6 months.
Yeah, but like how much of it's pretty much ABI compatible?
Yeah, it should be. Yeah.
I'm curious. Just, I mean, like if you're going to use LD library path anyway.
Yeah,
If you knew a little bit more about what the users were like, or at least certain things, you could say, well, this ABI didn't change this time, and then they would be able to.
Yeah, no, but in 90% of the cases, that's changing the stage is not an issue. But there's always somebody that is loading a specific version and that doesn't work, or there's a small details of linking against particular version of libraries, not against the .so but .so something. That kind of that sometimes breaks things, but that's for a very small amount of users.
Do you have a space for ill-behaved software, like a place where you put user software of people that are annoying and keep asking for things that are weird, like outside of your stage? Did you just put something like a zoo for the animals?
I'm not sure I get the question. If we have some place where we deploy software,
where you're just like, this version's not going to change. This user's always going to use this version. This thing needs to be supported. It's going to stay over here, and you're not going to stage it because there's no point, and it doesn't change stage to stage.
No, we are not doing that. We might think about it, but the problem is that then you might have interactions between different communities. Like if somebody needs particular version of HDF5 and somebody needs the newer one, then some without noticing they might be loading different, thinking they are loading one and loading the other as things change. So you can have software and versions that are available throughout all the stages, even if they are all versions of software.
This area might be outside of your regular tree, like a place that you may not even be your spider cache or something. You would just use it in, and the users would sit over there, and because they're weird.
We are not doing it. We're not doing it. It's something. I mean, it's technically it's feasible. It's totally feasible. But I wonder if that would be a hassle, because then you will have on that place, for that version of that, you will have to have a particular tool chain, and then maybe somebody wants to have that with a different one, and then how that will play together with the other
user other than that one weird user know that it's there. Even like you don't like I wouldn't put it in anywhere that a user could find it accidentally. It would only be really.
You mean for a single user, having a place where we deploy things for a single user? No, we don't do that, and we are not planning on doing that.
You point to the documentation and you explain how to do it themselves.
Yeah, and actually, I think that's the best thing for everyone, because then it's everything under their control. They make sure that everything is exactly as they expected. Marcus has a comment, question, or something.
It's more of a comment, so I'm not sure whether everyone is aware of that, but in principle you can also configure EasyBuild when you use the hierarchy in such a way that it when you load a compiler, for example, it also extends the module path to a directory in the user's home, if it exists. Yeah, so it's that. Yeah, so I implemented this some time ago, that a user can have basically his local modules. And if you're using the hierarchical module scheme, you can also have the hierarchy within the user's module tree.
So that's how you handle my crazy case.
Basically, yes, and you can set it up. I mean, that's a little bit tricky. That's not yet supported by EB directly. You have to do some hacks to actually make it work in such a way that the user could use EasyBuild to install stuff into his home directory. Picking up as much as possible from the system.
Yeah, well, I think it's a use case that comes up a little bit.
So we talk about an automated hierarchy within user's namespace. That's what we are saying here, right? Very interesting. If that can be combined with the concept of stages in your case, build set in mine, and the concept of different microarchitectures, that will be so brilliant actually. It will solve so many problems.
Yeah, maybe it's something interesting to look into the hackathon, see how to actually take advantage of that. I wasn't aware of that possibility.
We don't have it enabled on Eureka, but it's in principle it's there.
Yeah, that's what I'm saying. I didn't even know that it was there. So, is there any other comment, question? Can you pass the mic? I think it's on there.
My question is that do you handle commercial software as well, or is the user responsibility?
We do handle commercial software, but not a big set of it. We have some.
And then how do you solve that one? Because I guess because most of the commercial stuff comes in binary, and then of course you don't stage them.
Yeah, the software that comes on simply binary form is deployed in dummy. Software that is commercial but it doesn't come on binary form, we tie that to particular groups. So if the user doesn't belong to the group, can't access. It just doesn't have the file system permissions to access the software.
But they steal the module, but
they see the module. They know that it's available. They know that it's installed, but they don't have access to it. Okay. To have access to it, they will have to send us an email or a fax, very new technology, and saying basically that they bought a license for that software, and then we will add them to that group.
Thanks.
And yeah, and I think that's regarding possible changes. That's more or less everything I wanted to say. When somebody suggested, and it's maybe worth a discussion, an internal discussion as well, is how to present packages to people that don't care about compilers and MPI runtimes, or I just want to run this software. I don't care. I don't know what is the difference between the Intel or PGI or anything. So we might have to look into presenting that things potentially over different communities and have maybe set of packages for bioinformaticians, set of packages for whatever, set of packages for visualization. Mm-hmm. Okay. But even there's also users that they need MPI, but just they don't have the expertise they don't know what is the difference between the different MPI implementation. Exactly. So. No, Spider is good enough. Spider helps, but if they don't know which compiler they want to use, they don't know what the Spider is telling them. Or you're exposing your user maybe a little too much rather than API, and you're making them pick something. Yeah, you're right, but there's always different kind of users, and there's users that develop their own code that they are very experts on different compilers. Exactly. So that's more or less what I'm talking about here. There's for cases where they know which compiler they want, and there's a lot of those users that is perfect. For those ones that don't know what this thing is about, we might want to present a different way of presenting software. Then another thing in your setup that can help with that is we have a shortcut for loading the toolchain with Intel, Parastation, MPI, and KL, and that shows everything. That's our default toolchain. But that's the only toolchain that is available. So what I mean is that instead of making module load default to see what is the default, is right now it's module load Intel Para, and then they will see all the software that is available on the default toolchain. That may be a matter of educating or having better the users or having better documentation to make clear that if you don't care about all this stuff, MPIs, compilers, just load this one and you'll have everything you need. And there's Alan is raising the hand like crazy.
I mean, and that was one of the things we implemented as well. That's maybe not on the slide deck, but these module naming scheme independent installations, right? So the installations don't change, but I can give another module view to a particular group of people, right? It doesn't change the. It doesn't. There is no hierarchy. The installation, the directory is just unique. It just uses the flat scheme that's used by EasyBuild, right? So as long as it just needs to be unique, right? The problem, one of the problems with the hierarchy, sometimes it's not unique, or at least the view is not unique. But yeah. 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 Yeah, okay, it doesn't go that deep at the moment. At the moment, it just goes at the level of the naming scheme, but it doesn't talk about, yeah. 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 It's unique architecture in that sense, yeah.
Well, I think I'm like half an hour over time. Whoa. Oh. Now, can't read. No, panic. Well, just there's just 3 slides more. We will deploy EasyBuild on new systems. We're seeing Julia and Jerome based on KNL and on Power8 respectively. We are looking into it. We are not promising it, but we are very interested on having something more homogeneous about across all our systems, because at the moment it's a bit of a headache for us, and it's a headache for the users as well. And interesting also is the Eureka Booster, which is that comes from the idea that we're seeing on the old computing room with the deep system, to kind of tie together a booster, a set of KNL nodes into your Eureka, and make them, both of them work together. And for that, they need to have a more or less common software environment, even though there's different microarchitectures. So that's one of the things why it was interesting to have this ---- op arch extended to support different architecture flags for different compilers. So then we don't have to be redefining every time we compile something. It can be set on the environment, and that will be it. So yeah, well, to conclude, yeah, EasyBuild help us a lot, enable us to deploy a tremendous amount of software. There were a lot of work though to adapt it to our environment, and yeah. So I don't think there's anything really here that we haven't mentioned already before. There's still room for improvement. I hope at least to have some time during the hackathon to work on the things that I would like to improve about EasyBuild. And that's it. So, questions? More questions besides the ones that we already had. For the people on the internet, they are clapping. Okay, so let's go for the